orient themselves during the flyby. The Lunar Targeting Plan provides a detailed timeline of observation targets, background science context, and specific instructions for the picture the crew should take, and verbal descriptions of what will be helpful to the science team reviewing those pictures later. That's what we've been tracking real time and what the crew is using right now to keep up with their next milestones. We often see on the near side of the moon and that we can all see from Earth.
All right, cabin is still full of excitement. We've got Christina in window 2, Ike in Victor in window 3. Reed's actually been trying to get some images out of the docking tunnel. We can see the Earth and the moon and part of the moon out of the docking tunnel, which is pretty good. And I'm just grabbing some footage right now with our interior cameras.
Copy, Jeremy. We'd like to know what camera Reed is using and also the status of window 1. Looks like there might be a shroud removed.
Okay. Reed was using the Z9, and the T-shirt shroud is still on window 1, but we took the camera out of it. So maybe that's what you're noticing. But when I looked in there, I saw a lot of sunlight reflecting around.
Copy. That makes a lot of sense to us, Jeremy. I want to remind you, coming up on this LOS, it will take sit reps in the blind. And as more and more of the moon is in darkness, we will take any report you have on impact flashes.
All right, Jenny, you'll have to say again your last. There's a lot of conversation here, and I was on the other side of the cabin, so I missed all of it.
Look out for impact flashes, and we'll take sit reps in the blind.
Okay, impact flashes, sit reps in the blind. We got it. And yeah, just so you understand what's going on with window 1, there is light coming through the outer hall from window 2 into the inside of window 1, if that makes sense. Like I can see the inside of the vehicle when I look between the 2 panes of glass.
Copy.
You're getting your first live look at Orion, the moon, and the Earth. Everyone in this picture. This is a live view from the Orion spacecraft. Currently aboard Orion, 4 crew members, Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen. And on the Earth, all of us, all of humanity. You can see the moon is starting to get a little bit dimmer as the astronauts are going to pass behind it, now 6 minutes and 26 seconds away from that loss of signal. Again, we will be out of communication with them for about 40 minutes until they come around the other side of the moon and we can re-establish contact.
Integrity Houston, you are 6 minutes from your 40-minute lunar flyby LOS. From all of us, it's a privilege to witness you carrying the fire past our farthest reach. Thank you. Godspeed.
Thank you for that, Jenny. And thank you to all of you for allowing us the immense privilege to be on this journey together. It's quite amazing. And as we go on this journey, thinking about the NASA mission to explore the unknown in air and space, to innovate for the benefit of humanity, and to inspire the world through discovery. And as you've gone along on this journey with us, hopefully we're doing just those things. And as we get close to the nearest point to the moon and farthest point from Earth, as we continue to unlock the mysteries of the cosmos, I would like to remind you of one of the most important mysteries there on Earth, and that's love. Christ said in response to what was the greatest command, that it was to love God with all that you are. And he also, being a great teacher, said the second is equal to it, and that is to love your neighbor as yourself. And so, as we prepare to go out of radio communication, we're still to feel your love from Earth, and to all of you down there on Earth and around Earth, we love you from the moon.
Houston copies. We'll see you on the other side.
We will see you on the other side.
Poignant words from NASA astronaut Victor Glover, and a little bit of a love letter from the other side of the moon all the way to Earth. Glover touching on the teachings of Jesus, including to love your neighbor as yourself. We are now less than 3 minutes away from loss of signal with the Orion astronauts. The Artemis II crew will be out of signal for about 40 minutes as they are on the other side of the moon, continuing their work photographing the lunar surface, and they will reemerge, and we will also get this view on the other side. Just about a minute and a half now until we lose communication with the astronauts aboard Orion on the Artemis II mission. Now, 5 days and 6 minutes since their launch on April 1st. Again, we'll be out of communication for about 40 minutes. And this really beautiful view of a crescent moon and a crescent Earth. How great thou art. 30 seconds now until we expect loss of signal. And we have confirmation of loss of signal of the Orion spacecraft as it flies behind the moon. We expect to regain communications with them in another approximately 40 minutes. This was expected as their spacecraft is now out of direct line of sight with Earth and behind the moon. And this is a poignant moment as it's the first time in over 50 years that we have humans completely unreachable by anyone else on Earth. No matter how distant or secluded, we could reach anyone living on Earth, but while the crew flies behind the moon, it's simply impossible to make contact with them. This is a live view inside the Science Evaluation Room here at Johnson Space Center and just down the hall from Mission Control. This team has been monitoring the flyby all day as the team has continued capturing targets on the lunar surface. We even got to see this team in action as they were helping the astronauts identify some of the features they were seeing on the moon but not expecting. A couple of milestones during loss of signal. The first will be when the astronauts make their closest approach of the moon at MET 5 days, 25 minutes, and 34 seconds, when we expect they'll be 4,067 statute miles above the lunar surface. Their maximum Earth altitude will be reached just 2 minutes later at 5 days, 27 minutes, and 39 seconds, when their altitude should be approximately 252,756 statute miles. Once those milestones are reached and we have confirmation, we will report the official numbers. Throughout the Artemis II mission, astronaut voice, images, video, and vital mission data must traverse thousands of miles, carried on signals from NASA's powerful communications systems, the Near Space Network and the Deep Space Network. Let's learn a little bit more.
NASA's Artemis II will send 4 astronauts around the moon, preparing humanity for a long-term lunar presence and future journeys to Mars. Enabling communication and navigation for this test flight are NASA's Near Space Network and Deep Space Network. With antennas around the world and a fleet of relay satellites, the networks will deliver vital data to and from Earth through all phases of the mission. The networks are seamlessly integrated at NASA's Johnson
on Earth. Their tasks for lunar flyby did not stop as they went behind the moon and out of contact with us. We anticipate during that time they were attempting to image some impact flashes, short-lived flashes on the lunar surface, which would be caused by impact bombardment and potentially even lofted lunar dust. Right now, of course, they are getting pictures of Earthrise. After this target, they will get a short observation break. It's about an hour long, actually.
Houston, integrity, comm check.
Integrity, we have you loud and clear. Tell me.
To hear from Earth again. To Asia, Africa, and Oceania, we are looking back at you. We hear you can look up and see the moon right now. We see you too. When we burned this burn towards the moon, I said that we do not leave Earth, but we choose it. And that is true. We will explore, we will build ships, we will visit again. We will construct science outposts, we will drive rovers, we will do radio astronomy, we will found companies, we will bolster industry, we will inspire. But ultimately, we will always choose Earth. We will always choose each other.
Integrity from Earth, our single system, fragile and interconnected. We copy. Those of us that can are looking back.
Leave Earth, we choose it. The translunar injection burn served as not only what put them on this trajectory to fly around the moon, but what also committed them to splashing down in the Pacific Ocean on Flight Day 10. Very busy day taking pictures, making annotations, making audio recordings, and communicating all of the wonderful things that they are seeing on the moon. This observation break is also partially due to the fact that we will be entering an eclipse later. This will be the first solar eclipse that humans have seen from the moon. The astronauts will need to wear eclipse glasses for the first 2 minutes until the sun is completely covered by the moon, and then they have additional targets that the science team is hoping that they will photograph. We will have communications with them during that eclipse time frame. Orion's attitude must be changed right now so that its solar arrays are in the sun. This will help it charge the batteries needed to power it through that eclipse time frame. Visualization. The spacecraft now 4,224 miles away from the moon, and that number will now continue to grow, while the number of distance from Earth, 252,699 miles, will continue to shrink all the way until our crew is back home. This current attitude maneuver helps charge the solar arrays and batteries aboard Orion that will power them through the eclipse.
And your flight director have flipped their Artemis II patches around. We are earthbound and ready to bring you home. Team in Artemis Mission Control in Houston and brought us each a patch. Everyone in the flight control room has had these on their signifiers at their console. On one side of the patch that you've probably seen is the moon with the Earth behind it. Now that we've passed behind the moon and we are returning home, the flight control team has instructed everyone in the room to switch their patch around so that the Earth is closer and the moon is behind us. We are really looking forward to seeing the Artemis II crew. And the Capcom, Jenny Gibbons, did call that update up to the crew that the flight control team here has turned their patches around, as was instructed by the crew during that last sim. And we are counting down the days until they get home. They are now 5 days, 1 hour, and 3 minutes mission elapsed time into the Artemis II mission.
day. Everyone's been buzzing. I can't contain myself. So it's been a really awesome day.
So you're sitting on console at the science console now. Have you been in the SIR earlier today?
There's a lot going on. So I went here first, and then I'm going to go there
Angela
after.
Garcia, Artemis II Science Officer. Thanks for being here, Angela.
It is an honor to be here.
Hi, Integrity. We hear you. That was a little clipped, but I think we have a better link now.
So it's been a really awesome day.
So you're sitting on console at the science console now. Have you been in the SIR
we
earlier
are
today?
in bias, tail to sun.
There's a lot going on. So I went here first, and then I'm going to go there after.
Okay, Houston, you're coming in loud and clear.
Hi, Integrity. We hear you. That was a little clipped, but I think we have a better link now. We experienced some blockage from a solar array. Affirm. And Integrity, just so you know, we are in bias, we did not hear your response once we flipped our patches. Jeremy, we heard you call down, but you were clipped, and then we briefly lost comm. Glad we're back.
Okay, Houston, you're coming in loud and clear, and copy, we're in bias, tail to sun now. Okay, copy that. We were just excited that we got to share that you use the mark.
And Integrity, just so you know, we did not hear your response once we flipped our patches. Jeremy, we heard you call down, but you were clipped, and then we briefly lost comm. Glad we're back. Our pleasure.
So can you tell me a little bit about your role supporting Artemis II in the science preparation for the mission?
Yes, so I'm one of the 3 science officers. So Kelsey's been on console all day. I'll take over kind of closer to the end of the day. And then Trevor Graff is on the planning shift. And so it's the 3 of us in this 24-hour cycle supporting the mission. And so the science officer console is a brand new console to mission control. And it's not every day that you get
preparation for the mission.
A new discipline incorporated. It's been such a significant milestone for us, and it's just a testament to like the commitment that the flight operations So the science officer really console is a brand new console, and then the science preparation, and it's not every day. So I'm on the operations team, but I'm also on the training team. So all the incredible training and shout-outs that you've gotten today, just milestone for us, and it's just a testament to everybody's heart in the science evaluation room. I promise you that. But to all the classroom training, the field training, the mission simulations, really exciting. We were and that is what we did to get the crew to be. They are a part of the science team, and they are the forefront, that nice edge, and they're just been doing such a great job today.
I know. I imagine that you have to be pretty proud of them. Their reports have been fantastic. So I would like to know a little bit about how you have developed procedures for this crew. What kind of science activities are they carrying out inside the spacecraft?
Yeah, so the procedure development has been a unique challenge. I would say the exploration science that we're doing is inherently pretty flexible, and operations is, I'd say, inherently has more structure and rigidity. And so to marry the two and to operationalize the science that we want to get done has been a challenge. But I think we've been able to go through these processes and create good products at the end and have a good plan. And yeah, it's been really great. What was the second part of your question?
Just what kind of these science activities that they're performing, which of those have you really had a hand in?
Yeah, so a lot of the procedures help organize what the crew is doing in the cabin. And I know we've talked a lot about what they've been doing, and they've been doing a lot, and it's been a little dark, so I can re-explain what some of those things that they're doing. So the observation blocks are about an hour long, and the crew is organized, the 4 crew members are organized into 2 pairs of 2, the window team and the cabin team. And the lunar targeting package that you've been showing up and that the crew have on their handheld tablets is really the instructions for the window team. So the window team, the 2 crew members are looking out the window. One has the camera with the long lens. One has, they're just looking out the window with their unaided eye, and they're taking these detailed observations. And then halfway in that observation block, they do the window team position swap. So that's what Capcom's been calling out, and they'll switch positions, so each crew member has a chance to have that long lens. And then that's just what the window team is doing. There's also the cabin team, where they also have duties that they're doing. We're asking a lot of the crew in this time. And then the cabin team, they have the interior camera, and they're taking images inside the cabin. They're also supporting the window team where, you've heard some call outs where looking out at the bright moon and then looking inside the dark cabin and looking at their LED screen is a lot. So the cabin team is also helping support, target, and guide the window team into specific targets on their plan. They're also helping call out these science situational reps. So they're looking out a different window and listening in to what the crew who are really down and in the science on the window team are doing, and they're giving us insight. And those recordings that the window team is doing are going to be uplinked or downlinked overnight, and we're going to be able to chew on that data. But yeah, they're helping. They're doing a lot. And so making sure we have a plan that's flexible, but also make sure that we check off all those boxes was really important.
So tell me a little bit more. You talked earlier about the analogs that the crew has done. What kind of analogs or environments were really useful for this?
Yeah, so for procedure development, right, you have so many different environments that you can do. You have classroom, like we said, you have the Orion mock-up, you have simulations, and at least for developing the plan, we kind of did it in a tiered approach because each of those different analog environments helps us answer a slightly different question and has a little bit of a higher fidelity. So we would start with the classroom. So we would get we would just get into a classroom, we would put all the hardware on the table, and then we'd almost role play of like, you be Victor, you be Reed, you be Jeremy, and I'll be Christina, and like, let's just do the plan how we think we should do it, write that down, and then just keep iterating on that, and then
Integrity Houston for a tag up pre-forward link LOS in place of the Flight Director Conference.
Okay, Jenny, we're ready.
All right, crew, I'm going to roll through a couple of topics here. The first two are for timeline. First of all, Reed for your toilet maintenance. It is a shortened toilet maintenance where you do not have to do the oxone changeout. That portion of the procedure is canceled. Victor, you have an HHP stop activity on your timeline. We need you to perform that as scheduled for bandwidth reasons. For your next portion of the flyby, in particular the eclipse, we want to remind you that you can take off the eclipse glasses when the sun sets and you are simply looking at the corona. And then finally, for the D5 with the long or zoom lens, which is set for solar corona, we want to remind you that when you are capturing Earth shine, you will likely have to adjust the exposure. That's all I have for you. Let me know if you have anything for us.
Okay, Houston, we copy all. Thanks for those words, Sydney.
Right, just a quick call up to the crew ahead of a forward link LOS, meaning that we won't be communicating with them, but we will be receiving their communications and data during that time frame. So Angela, we were talking about analog environments. You were telling me about the classroom and getting in there and pretending who's Victor, who's Reed. Tell me more about this.
Yeah, it works pretty well. So you're going to do the plan how you expect it to be, and then once we finalize that plan, we'll give it to a completely new group of people and have them practice it, and then they'll be like, these steps don't make sense, and we'll reiterate on it over and over. And then we'll take it to a higher fidelity environment like the Orion mockup, and we'll do the same thing because that volume is smaller, the window placement, their seating, what things have we forgotten with this addition of this environment. And then once we reiterate on that, we'll take it then, we'll give it to the crew and have them execute off of it during mission simulations. That's the highest fidelity that we can do before we send it to space. So this is the first time we've had to do this because we're a brand new console, and it just sparks so many neurons of like, how are we going to do this for surface missions and integrate this in so many different ways. So excited to have kicked off this process, but there's so much more to come.
Fascinating. And I think it was really well thought out too, because each crew member gets an opportunity to do each task. And so you're getting different perspectives and different insights from each crew member, maybe even about the same target, but something that one person sees could be completely different than something another person notices. So we also know that Artemis II has traveled. They're now on their way home, but they traveled farther from the moon than the Apollo missions did. So what makes that vantage point scientifically interesting?
Yeah, observations are so fundamental in the scientific toolkit, particularly observations from different perspectives, different scales, and with different techniques. And so for this, so we really tried to make the plan to optimize those. There's pros and cons for all those things for this mission. So we really just focused the plan to have all those pros. So in terms of scale, this zoomed out scale, you can learn different things. This different perspectives. So their perspective, as Kelsey talked about, photometry around when they orbit the moon. And then also just their different the different things they're able to observe. So yeah, let me talk a little bit about scale, because I think observations at different scales, you can gain a lot of different information. So like, for example, if you were an astronaut on the surface looking at a rock, and you describe at this micro scale. So in training, we kind of talk about observations from micro to macro, or from outcrop to orbit. So looking at a rock at this scale, you can describe its components, you can describe what it's made of and its colors and its minerals, and you're like, okay, and this rock came from this boulder, and it's this part of this boulder, and these are the different things that I'm observing around. It gives me context to this sample, and then you zoom out a little bit more, and you're like, okay, well, I can see that this boulder came from, it rolled from this mountain ridge, or this high ridge feature. And then because I can see the trail that it came from, okay, now let me describe this ridge, and different parts in it, and maybe other boulders that I'm seeing. And then you zoom out further of the orbit scale, and you're like, this ridge is a part of this larger crater. So all of those different steps give you different information, and so that's why observations at these different scales and these different perspectives are so important. So this zoomed out kind of far view is this full lunar disk view. It's the full lunar. On Earth, we see the full lunar disk as well, but now we're able to see it on the far side, and we're able to see it, all at the same time, which enables the astronauts to compare very quickly to different parts of the surface. And the color particularly is very compelling, because you can just be able to very quickly compare from 3 different regions. Is it in the same family? Is this actually a little bit different? Compare that to what they see in their orbital data that they have access to on their portable computers, and really just be able to tease out that nuance and information.
Yeah, we heard them make a lot of those connections today, and especially the color. We talked with Kelsey about this a little bit, just how exciting it was to hear the browns and greens and things like that. I cannot wait to see those pictures. So one last question. We are coming up on the last lunar flyby observation block, and this is when we are going into a solar eclipse. So can you tell me what you're interested in the crew learning during that time frame?
Yeah, so the data set. So yes, there's so many things. How to pick one. So I'd say the thing that I'm most interested in seeing is some of their annotations that they're taking. So in this opportunity, it's a very dynamic type of experience, in that we don't normally see this activity. And so being able to have crew observe the solar corona, and then also annotate it in their on their portable computing device is just such a unique thing that humans can give to missions, and also particularly being able to annotate what they're observing while they're talking about it is also unique to being able to have astronauts in orbit as well, because we won't be able to have annotations on the lunar surface, because the astronauts will be in suits. They're going to be collecting samples, they're going to be deploying instruments, and so personally, I'm really excited to see some of these annotations and to see how that develops over time, because you've heard a lot of descriptions, and I think when people are describing something that's unique and different, you can interpret it differently. But if you're drawing and you're marking, particularly just going back to like the color provinces, for example, and those boundaries, you know exactly what they meant. And really, I'm just very excited about those annotations. There's been some famous annotations that the Apollo crew have made, particularly about solar coronas and the structures that have, and lofted dust that have given a lot of debate within the scientific community of they're observing this phenomenon, and now it's our job to hypothesize of like why are they observing this, like what is going on. So I think that's just a really cool part of exploration and science, and this beautiful thing that we're about to do.
Well, now you've got me excited about the annotations too. I mean, I've been excited about the pictures and the audio, but now
don't sleep on the annotations. I am very excited to see these little sketches that they're able to draw out, and we have pictures that they can just draw right on. It's like this particular thing is different than what we've seen, so I'm excited about that.
I'm excited too. Angela Garcia, thank you so much for joining us today, and have a great time tonight on Console.
Thank you, and you've been doing a great job, and it's so excited to see where we go from here.
Thank you so much.
Integrity Houston, you have 3 minutes until we go into a forward link LOS. We will be back up with you in about an hour during the eclipse on Madrid.
Thanks for the heads up. Look forward to seeing you on the other side.
Likewise.